Hello, chemistry students. All right, so we are going to look at another example here of how to use indicators and how they kind of work in terms of the range and the colors. So, example problem here, a substance has a suspected pH of 4.5. What are two indicators you could use to verify the pH? So, if we know that this has a pH of 4.5, we know what we're kind of looking for in terms of numbers. This is the table that's on the back of your periodic table. And all it is it's got all the different indicators, their chemical formula, the pH range they work for, and then the colors that they work for there. This Ka is to do with Chem 30 stuff. So this is the list that's on the back of your sheet. So what we're going to look here is trying to find two indicators that might help us verify this. So one thing with these indicators is understanding like they're accurate, but of course it comes down to understanding colors and looking at colors and interpretation of colors. So sometimes they can get a little bit finicky in terms of what you're going to be looking for, but on the chart we can easily kind of use and identify and expect what colors we're going to be looking for. So since we're looking for a pH of 4.5, we should just kind of go through the list and find any that will be close to 4.5. So we've got one right here, 3.2 to 4.4. There's one. This one's in the 4.5 range. This one is another one in the 4.5 range, kind of is a little bit above. And this one, let's just keep on going. We want to look at anything that's possibly inside the range or very close to 4.5. So that's pretty much those three. So we're going to look at methyl orange, bromoscale green, and methyl red. So I know the question asked for two, but we're going to look at these three and break down how we can look at how they'll give us a range of numbers. So if we start with methyl red's got a range of 4.8 to 6.0. So if we go back to our other page and just write all this down, so methyl red has a range of 4.8 to 6.0. So let's look at this even closer, and we'll look at 4.80 to 4.8, 4.9 to 5.9, and then 6.0 all the way to 14. So here's kind of my three ranges that we have to understand that they're going to get varying colors with this. So if we're looking at it from 0 to 4.8, methyl red is going to be red from 0 to 4.8. From 6.0 to 1.4, or sorry, to 14, we are going to have a color of yellow. So when you combine red and yellow together, well, you're going to get orange. And luckily, we've got orange. So if we're using these three indicators and we're going, this first indicator, and we use our unexpected substance up here, we're expecting a pH of 4.5. So if we use that, the color we should get is red. So this is the color that we're expected to get from this. So if we're doing a test and we put this unknown solution into methyl red and it comes out red, well, that tells us our range is 0 to 4.8. Okay, so that's kind of one thing that we can do, that first one there. Next one we can do is just to give us a even better one. Let's look at Bromsco green. Bromocresol green, sorry. So Bromocresol green has a range of 3.8 to 5.4, and that goes from yellow to blue. So from 0 to 3.8, we're going to have yellow. 5.4 to 14, we're going to have blue. And then 3.9 to 5.3, we're going to have the combo of those two. So first one, we've got yellow. And then this side, we're going to have blue. And in the middle, if you combine red and blue, it's going to be green. So if we're using this and we're expecting our range of 4.5 and we test this, we should expect it that it's going to come out green. Now, if we all of a sudden got yellow, well, that would tell us that, okay, it would still confirm this, but our yellow means that our pH would be actually below 3.8. So this wouldn't be true. So that's the difference here is we're getting ones that this gives us a range of 0 to 4.8. If we use something like this, it's going to confirm, well, is it actually below 4.8 or is it actually more in this range? And if we got a yellow, well, that would tell us, well, it's actually in the lower range of this. If we're using the green, it's actually going to be in that 4.8 range to what we're looking for. Last one I've got is methyl orange. And that was back, just to go back to our last page. So we went through methyl red, we did Bromocresol green, and now we're going to look at methyl orange. So we looked at these different ranges. They're around 4.5. Last one, if we're looking at methyl orange. So methyl orange has a range of 3.2 to 4.4. So from 0 to 3.2, and then 3.3 to here's the different ranges we can get from this. So methyl orange will say the range and it'll tell us the colors. Our actual range is going to be, if it's below 3.2, well, it's going to be red. If it's above 4.4 or above, it is going to be yellow. And then between those two, we're going to get orange, right? Because if you combine yellow and red, you're going to get orange. So looking at what we've got here, with our expected 4.5, we got 4.8, which was red, below 4.8, which was red. We got this one to be green, which again falls into our 4.5. And then this one, since it's in this range here, this one's actually even more close to what we're looking for. Because if we get orange, well, it tells us, okay, you could have this one and this one falling in that range still and still get orange color. And that tells us it'd be below this 4.5. But if we get a yellow color, it's going to get confirmation of all those. So if we get yellow, and our final one being yellow, that's how we know that this one would be true to be that 4.5. This range, 4.5, lies in this range, 4.5 lies in this range, and then 4.5 lies in this range. So this would be true. If all of a sudden we're getting different colors, we would get confirmation that what is said isn't true. So that's one way of looking at the indicators, and an example problem of something you can